The reaction is A plus R giving us product. The rate of the reaction depends on concentration of A, concentration of R. So this is a second order reaction, and the initial concentrations of A and R are given to be A naught and R naught, which is equal to 10 A naught, and at T 40%, when the reaction is 40% complete, because A is the limiting reagent here, 40% of A will have reacted by T 40%. So A minus of 40% of initial concentration, and because of the stoichiometry of the reaction, 1:1 ratio is how A and R react. So 10 A naught minus 0.4 A naught. This will be the concentration of R. Now the true rate is K times true rate at T equals at T 40%, let's say. So K and concentration of A at that time will be A naught times 1 minus 0.4 times the concentration of R, which is A naught 10 minus 0.4, which is 9.6. So the true rate will be this squared. 1 minus 0.4 is 0.6 and 9.6. Now if we assume the reaction to be pseudo first order, with the rate of the reaction depending only on the concentration of A, because concentration of R is much larger than concentration of A, and assuming the new rate constant to be constant, which is equal to the original rate constant times the concentration of R. The concentration of R that we are taking here is the initial concentration of R, which is R naught. And the whole idea behind pseudo nth order reactions is that it's a mathematical trick. We are hiding the variable, assuming it is a constant because it is not changing much. And this, if we want to represent it in terms of everything in terms of A naught, this is K10 A naught. Now the relative error in percentage is the cost of this approximation. How much is the error? So relative error is defined to be the difference in the assumed value and the true value, the magnitude of that difference, and divided by, compared to the true value. And this is a fraction, so times 100 will give us the percentage value. So assumed rate R at T 40% will be K times 10 A naught times concentration of A at 40% completion of the reaction, which is the same, A naught times 0.6. So this is the assumed rate, K 10 A naught squared 0.6 minus true rate, which is this, K A naught squared 0.6 9.6 divided by the true rate, which is the same as K A naught squared 0.6 9.6 K A naught squared K A naught squared K A naught squared times 100%. 10 times 0.6 is 6 minus 0.6 9.6 divided by 0.6 9.6 will be 0.0417, and times 100 will give us the relative error in percentage, which will be 4.16.